Hey guys, welcome back. So what we're looking at today is lesson 10, the distributive property part 2. So let's go ahead and jump right in. All right, so what we're looking at here is dealing with unknown lengths. So here are two rectangles. The length and width of one rectangle are 8 and 5. The width of the other rectangle is 5, but the length is unknown, so we labeled it x. Write an expression for the sum of the areas of the two rectangles. So being as we have each of these, we know the area of this part is going to be 5x because it's 5 times x. And then we're going to add the 8 times 5 to it. So we'd have 5x plus 40. So there we look at it when it's separate. Now, the two rectangles can be composed into one larger rectangle as shown. What are the width and length of the new rectangle? So the width didn't change. It's still 5. So width 5. Length, though, now we're combining the two lengths. So our length is x plus 8 because it's all one thing now. So x plus 8. Now, to write an expression for the total area of the rectangle as a product of its width and length, well, we're just going to multiply these two. So 5 times x plus 8, or x plus 8 times 5. Either of those work. So there's our expression. So this is the distributive property, and these are equivalent expressions. So equivalent is your key word for this lesson, equivalent. All right. Areas of partitioned rectangles. For each rectangle, write an expression for the length and width and the two expressions for the total area. Record them in the table. Check your expressions in each row. Obviously not with your group. But, so let's take a look at this. In A, we have a width of 3. Let me make this a little bigger so it's easier for me to write. Okay, so in A, we have a width of 3. What is our length? Well, A and 5 together, so A plus 5. So, writing it as a product of width times length, we're going to have 3 times A plus 5. Now, as the sum of the smaller, use the distributive property. 3 times A is 3A, and then 3 times 5 is 15. So we just multiply both things inside the parentheses by what's outside. All right, width on B is 1/3. Length is 6 plus x, or you can do it the other way around. Either works. So then we're going to have 1/3 times 6 plus x. So 1/3 times 6 is 2, plus 1/3 times x is 1/3 x. All right, C, our width is r, and our length, there's different ways to do this. We have 1, 1, and 1, so we have 3, so I'm just going to leave it as 3. You could also do 1 plus 1 plus 1. So here we're going to have r times 3, so it's just 3r. We typically like having the number in front of the variable. Or technically, I guess, since it wants the sum of the smallers, each individual, we'll just say r, r, r. R plus r plus r. All right, for width on D, our width is 6. Our side is p plus p plus p plus p, or 4p. So we have 6 times 4p, which is the same thing as 24p. And then the sum of the smallers would be 6p plus 6p plus 6p plus 6p. All right, the width on E is m. Our side is 6 plus 8. So we'd have m times 6 plus 8. So this would be 6m m plus 8m, just multiplying the m to both things in the parentheses. All right, and our last one, f, we have a width of 5. Our length is 3x plus 8. And so we do 5 parentheses 3x plus 8. And so now 5 times 3x is 15x, and 5 times 8 is 40. So we have 15x plus 40. So these are all equivalent. We multiplied these through. We found out what it would be for the total area using those variables, having those in there. So now we can take and plug in any value for those variables and get our final answer. And we just multiply the number on the outside to both things inside the parentheses. Okay? All right, if you guys have any questions, feel free to ask. Have a wonderful day. Bye, guys.